Welcome to the continuation of the CI/CD pipeline. We already done with the first portion where we integrated Jenkins with Git. Now we come to the next tool that is part of our CI/CD pipeline, and this tool is Maven. Maven is very important, and of course, we are going to use it. I do have some notes here, and these notes are going to be available in this video. You can go through them exactly to understand what Maven does. For anything I do, I don't like just to come and show you the tool working. I like, first of all, to give you the concept so that you can build the knowledge that you need to know about the tool. Then, of course, we can go and do the practical part of it with the tool. So before we go to the practical, we need, of course, to know what Maven is, and also to know exactly why we as DevOps engineers or any other system admin or whoever, you need to know why you need to know or to be familiar with Maven. Maven, first of all, is a very important tool in your CI/CD pipeline. It does, and this is because of a few reasons that we are going to see here. One, it is the one that is responsible for dependency management. Whenever we talk about dependencies, you have to realize that Maven simplifies the management of project dependencies. Dependencies are nothing, but they are just the things that you need to download so that you can manage your project. It allows DevOps engineers to define and also declare the kind of dependencies or downloads that are in the central configuration file. And that file, you are going to see it, is what we call the POM XML, which is project object model. So what we do is that we are going to get the dependencies of the plugins or downloads that we need to use in our project, and we are going to put all of them inside the POM XML. And of course, that is POM XML is the Maven configuration file. So that is a configuration file that Maven is going to use to run your project. So don't forget that. Maven is then automatically going to visit the configuration file in the name of pom.xml, and is going, of course, to download all those dependencies that are required as part of the project. Build automation. Maven provides a powerful build system that is going to automate the entire build process. It is going to use declarative approach where the build process is defined. We are going to define the process in which the build is going to follow inside the POM XML file. With Maven, DevOps engineers can easily configure and execute builds, including compilation of the source code, because when we are making a build or we are creating a build, we have series of steps that we need to follow. And those steps are actually defined in the POM XML. In most cases, those steps are going to involve compilation of the code, the source code. And the source code, of course, is the one that we are cloning from the version control system of your choice. We are going, of course, to be running some tests. In our case, we are going to move to the next tool where we are going to be scanning and doing the static analysis of the code. We are also going to package the artifact and also, of course, convert the source code into binary code and package that into an artifact. Also generate report, and in some cases, we need to manage the artifact by pushing that artifact and storing that artifact in the artifactory of our choice. In our CI/CD pipeline, the artifactory of our choice is going to be JFrog. You can use Nexus, is fine. Standardization. This is another thing that is very important that Maven help us to do, to help us, of course, to standardize the entire SDLC process. Another thing that I want you to pay attention to is that Maven is very easy to integrate with other tools in our CI/CD pipeline. For instance, you're going to see how easy it is to integrate with Jenkins. We always say that Jenkins is a central tool. This is a tool that is at the middle of our CI/CD pipeline. And then it has tentacles, or it has ability to integrate with our other tools, and that is how it's able to create a pipeline. So as we're going, of course, to to integrate Jenkins with Maven. And when we do that, of course, our CI/CD pipeline is now going to get the ability to carry out the build automation process. Finally, we have dependency version management. As we said, Maven simplified the management of dependencies versions. It supports the concept of dependency scopes. Allow the DevOps engineers to specify dependencies based on their usage, compile time, test time, runtime, and manage time. So that's something you need to be aware of. So there are a few things I don't want you to get confused about. The first one is Maven responsible for converting the source code into binary code? Because some people think when we say that Maven is involved in the process of build automation, they start to think, okay, we are having the process of compilation of the source code, we have the process of building the artifact, we have the process of running some tests, we have the process of course converting the source code to binary code, and then of course somebody think that Maven is the one that is involved in that process. But I want to say no. So of course, no, Maven is not responsible for converting the source code to binary code. The process of converting the source code to binary code, which is known as compilation, is typically handled by a Java compiler. And this Java compiler, of course, is going to be part of our JDK. I want to show you something. That our JDK, either we can look our JDK in our Jenkins console, or we can go in the Jenkins terminal and say Java version. Let's see, nothing. So let's put hyphen, let's put some flags. Yes, so we do have the JDK, and this is what we are saying that is going to be involved in the process of compiling the code, because it has a compiler. Java compiler is the one that will be involved in the process of compiling the Java code, not Maven itself. So this we see that. So that's something I wanted you to know. Of course, when the compilation, the conversion of the code from source code into binary code and all that, we're going to have a final product. And that final product is what most people call the artifact. The artifact can be jar, can be war, can be ER file. It's whatever you produce it. So now, why must you have JDK available when you are working with Maven? Because if you don't have JDK available when we are working with Maven, we are going to have issues. When working with Maven, having Java development kit, that's what we call JDK, is very essential. One, compilation. Maven relies on JDK compiler to compile the Java source code into bytecode. The JDK includes the Java compiler JVAC. There is a Java compiler called JVAC, which translates your Java source code to .java file into platform-dependent bytecode to .class files. Maven utilizes the JDK to invoke the compiler and perform the compilation process. So if you don't have the Java JDK, Maven has nobody. It doesn't have anybody to invoke so that the process of compiling the code can start. And we have seen here that when you are compiling the code, of course, the source code is being converted into .java file, and then can be converted into platform-independent bytecode .class, and that's very necessary. That cannot be done by Maven. Maven is just there to invoke that process to happen. And that process, as we have seen, is usually done by the Java compiler, which is what we call JVAC. Java compatibility, Maven support different versions of Java, and JDK ensure that your code is compiled with the appropriate version. So you have to make sure that you have the latest versions. Depending on your project configuration, Maven requires the corresponding JDK version. So most likely in our case, as we have seen, let's go back to check the Java version, and this is on the Jenkins terminal. As you can see, we have the long-term support, of course, the OpenJDK 17. So previously I used to use 11. There is time I was using 8, but I think those are outdated because now we are talking about Java JDK 18, Open JDK 18. I don't know whether we have gone to 19, but 17 is okay. Dependency resolution. Maven manages project dependencies, which are external libraries or modules required by your project. Some of these dependencies might be implemented using Java bytecode and might require JDK. So apart from it, doesn't mean Java is still needed, because there are some dependencies, there are some downloads for them to work, for them to be downloaded by Maven, and for them to be part of your project, they still need a JDK environment. So those are a few things that you need to be aware of. Build lifecycle, plugin execution, those are all things that we need. So Maven is very vital. Now we have the concept under our belts. What do we do? The next thing we need to do is now to go to practical, because practical is now what we need so that we can see what this means. All right, so what we need to do is first of all to go to our Jenkins. And before I go to Jenkins, I have to make sure that I do have the Maven installed. I can either install Maven using the plugins, or I can go to this to the terminal of Jenkins, and I can install Maven from here. How can I do that? It's very easy. All you need is to run the command yum install mvn and see what will happen. As you can see, nothing to do. Let me do history. Make sure so this is how to install it. You see, so it's already installed. So let me copy this. It's not mvn, but you have to use the entire Maven name, and this one you are dealing with EC2, or what we call the Linux. But when you are dealing with Ubuntu, you don't need to do all that. Ubuntu, you just need to use a simple format. So we're going to just install. Let's see what happened. Yum install Maven, nothing. You can see that Maven is already in its latest version. So if I come here and I say mvn --version, I expect to see something. Yes, as you can see, and you see Java is also recommending you the Java you need to have. Here we have Maven, and is recommending that at least this Java version is JDK, of course, 17, and we do have that as we saw. All right, so we are done. We're good to go. Now what next? Next, we need to go back to our pipeline dashboard. This is the beauty of using the Jenkins container. We just need to log in again. Make sure you don't forget your password. Again, you see, because we have the build trigger, the build have continued to build even when we were away because of the build trigger. Now we need to come and configure, and to configure is very quick here. We're going to come here, and now we're going to move to the next stage. And this stage is now the stage of Maven. So let's revisit our pipeline. We're going to just copy the stage, and the stage is Maven clean build. It doesn't have to be called that. You can call it any other name you want. So you're going to enter, and you're going to paste. And immediately you enter, another curly bracket should form. So it means if it's not forming, I need maybe to activate it. Good. So now we are at that stage. This stage is a new stage, is Maven build, clean build. If you are familiar with bash scripting, we use def to define the variable name. In this case, we have a few things here we are doing. And I want you to pay attention to this, because we are defining a variable called Maven home. This variable is a combination of the two names, and the two name is Maven 3.8.6, and the type is Maven. But the question is, do we even know these two? No. So we're going to apply, we're going to save. So I want us to go back. So we're going to go to dashboard. We're going to come to dashboard, manage Jenkins. We're going to go to tools, and I want you to look at Maven. Maven, and I want us to install it. We're gonna install it here. We're gonna give it a name here from the console. So what we need to do is to come here. We go to come to the same name here. I want you to copy this name as it is. And then you come back to the name here. And you just, nothing else to do. Don't worry about anything else. It's just the name. Apply and save. So now we have put the name. So when the system is looking for this Maven with this specific name, it's going to find it because it's going to install automatically. After that, we have another definition. We are defining another variable. And in this case, this variable that we are defining, we have to go back to our dashboard and go back to our pipeline. And in this case, we're going to configure our pipeline. And we look at where our pipeline is. We are about, now we move to the next stage. We are defining another variable name called Maven CMD. Again, this if you have attended my bash scripting, this is very easy. So what we are doing here, we are using what we call string interpolation syntax, or string interpolation syntax, and we are using the $sign to reference to the variable name that we created here. So we are using this to call that or to reference to that. And of course, we are adding the path where to the central configuration, Maven central configuration location. And then, of course, we are adding this in the bin MVN. This is where we are going to find all those binaries that we need to download for our project. Finally, we come back to our pipeline, and we are going now to use the sh command. I'm going to let you know what this means. We're going to put it here. So what is sh? It means shell. So it's used to run shell command inside the Jenkins pipeline. Like if I want to run the command, let's say a command you already know how to check the maybe let's say you want to check the CPU in your Jenkins server. There is a command called nproc. So you can just come here and put nproc. So we use this to run the shell. To use this as a shell feature that we use to run any shell command or bash command here in the pipeline. In this case, we are just using sh to run any bash command inside the Jenkins server. So here is nothing. We are referencing to the variable that we defined here, where we have, of course, the tool name is defined. We have the type of tool is Maven, and we have the path defined. Now we are going to run that command and add a clean package, and we should be good to go. So now you're going to see some magic here, because what will happen is this Maven is going to reference to the POM XML. The POM XML is part of this repository. The POM XML contains all the dependencies that we need to build this project. It also contains the stages. It also contains the stages of how the process of building is going to occur. So all this is why we give it the path, we give it the name, and of course it's going to reference to the POM XML, which is a configuration file that runs Maven. And from there, we are going to see all the plugins or all the dependencies that we need to build our project. So we are good to go. We have to check here 1. We have to check 2 is good. That and that, the balance is there. Now we just need to apply, save, and now we are going now to enter here. And I'm going to say build. And let's see what happens. I just want you to check carefully. As you can see the dependencies are being downloaded from the central repository. You see, this is the central repository of Maven. This is where it's downloading all those plugins. And now there are many. Imagine yourself, you are downloading all these plugins to build your project. When are you going to finish this? And this is something that you do repetitively, because it's something you do in every SDLC project. So it's a lot of work. And this is why you need to automate some of these processes so that you can fasten the process of delivering the software to the end user. You can see now we have been able to build the process of building. Remember what we said that build is? Build is nothing but that process of compiling the code using the Java compiler. We are, of course, converting the source code to binary code. We are packaging those binary codes. And of course, we are coming up with an artifact. In this case, and of course, you see what I said, we use sh, of course, to run any bash or shell command. But mostly because we are dealing with Amazon Linux, which is a bash, or which is is a Linux operating system, and has bash, of course. This is where the bash scripting come from, because of this operating system called Linux. We have, of course, nproc. We were able to run this, and we see that we have 2 CPU here. And exactly because when I build this server from AWS is exactly 2 CPU. So if you want to run any command, any bash command on the Jenkins pipeline, you can easily use sh. As far as you are going, of course, to surround, of course, the name that you want to check or the command you want to check with double quotation marks. Why? Because the Jenkins pipeline doesn't know what nproc is. Therefore, it's undefined. And this is why we are surrounding it with double quotation marks. So now our pipeline is getting bigger. We started with Git. We have got to Jenkins. We have gone to Maven. So we started with Git, G. We have Jenkins. We have Maven. And all these tools, they are all integrated. So they have now formed a pipeline that is automating a lot of processes. Now, we are going to add our 4th tool, and this 4th tool is nothing but the SonarQube. So by the time I'm done with this video, because after that, we're gonna stop and then we'll continue another day with adding more tools into this. We are going to add more tools to complete the pipeline. But so far, I want us to make sure that we are good with 4 of them. So now we have Git, Jenkins, Maven. I'm going to add SonarQube. They are all integrated, so our pipeline is flowing, is able to get the water, is getting the water from Git, and it flow to Git. And it's getting, of course, we have GitHub here, where we are storing our code of the version control system. We have Git that is cloning. Then, of course, Jenkins is controlling everything. After cloning, we have the code is cloning to the Jenkins work directory. And then, of course, Maven copy the code from there and complete the whole process, of course, of building an artifact. Of course, we saw the series of steps it to take. And from there, now we do have an artifact. We need now to test the code. We need to see the code that was used to build this artifact. We need to do static analysis of the code. We need to see whether the code is smelling, whether the code is reliable, whether the code has a lot of duplication, whether the code has many maintenance issues. We need to see the technical depth in the code. We can only be able to do that by integrating Jenkins with SonarQube. That is going to be our next video. Thank you and see you there.